Welcome back, guys. Okay, today is September 23rd, and we are talking about density, and we're talking about regular and irregular object density. So this is our learning target for today. I can calculate the density of a regular object and an irregular object. Now, chemistry is half vocabulary. Once you know the vocabulary, it's really simple to understand what's going on and how to conduct certain experiments and calculate certain calculations. So with that being said, I want you to go ahead and determine the definitions for these four words. And I just want you to use the top of your head. You've been learning density since the second grade, so I want to see how much you know. This is not a test. I want you to challenge yourself. Let's see if you can really remember that the definitions of these words from your previous academic classes. So go ahead, pause the video right here. Try to think of the definitions and write them down. So if you've started the video again, that means you've already have your definitions. So let's go ahead and talk about them. Now, our vocabulary words, density means the amount of mass in a given space. The density formula can be found on table T of the chemistry reference table. It's actually the first one. Volume, the definition, is the amount of space an object takes up. Shoosh. Mass, how much matter something has, and weight, the tension of gravity on an object. Now, when it comes to chemistry, we end up using these two words interchangeably, mass and weight. But know that we're always taking the mass of an object, never the weight of the object. Always the mass. So, let's try this out and let's see if you can get it. Which box has the most density, box A or box B? Go ahead, think about it, and then when we have the live session, we can discuss it. Now, when it comes to a regular object, to find the density, we need to measure the volume, which we're going to take the length, the width, and the height and multiply them together. Now, the only reason we're able to do that is because all the sides of the regular object are straight. They're not curved, they're not bent, they're all straight. Then we take the mass using the scale, and then we divide the mass by the volume. And that's how we find the density of a regular object, as we've been doing since the second grade. Now, when it comes to an irregular object, you first find the mass of the object. It's very important that you find the mass first. We don't want to find the mass second, because what's going to happen is that once we find the volume, the water might add some mass to it, and then we get an inaccurate mass. So find the mass first. Then you're going to fill a graduated cylinder up with 50 milliliters of water. You're then going to place the object into the graduated cylinder, and the 50 milliliters of water that you had originally has now risen to a new number. So if we look at the image that I have on the side over here, you'll see that we had 50 milliliters of water, and then we had 75 milliliters of water once we place the object into the graduated cylinder. Now, your mind should automatically come up with what we have to do to determine the volume. But if you're saying subtract the two numbers, yes, we're subtracting the two numbers to find out the volume. Once we subtract the two numbers, we have the volume. You already took the mass, so then you're going to do mass divided by volume to get the density. We're going to come back to this slide. This slide is just to help you out. It does have the exception for liquid density, so we're going to come back to that. However, use this to assist you. Also, the diamond is very important. What I like for students to do when we are in school is to actually write the diamond or draw the diamond into their reference table, because I feel like that representation is a little bit more easier to remember than the formula sometimes. So now we have a couple of example problems. And our first example problem says the solid object shown below has a mass of 162.2 grams. And then it gives us the dimensions, the length, the width, and the height. What is the density of the object to the correct number of significant figures? Don't worry about significant figures right now. But I can tell you off the bat that this is a regular density problem because my object has length, width, and height. It has a straight edges. So that means I'm going to go ahead and find my density. I'm going to go and find out my volume. And once I have the volume, I'm going to go ahead and calculate my density. So for volume, my volume is length times width times height, right? So I'm going to take 6 times 3 times 2, and I'm going to multiply those numbers together, and I'm going to get 6 times 3 is 18, 18 times 2 is 30, 18 times 2 is... 18 times 2 is...
18 times 2 is 36.
It's 36. So my volume is 36 centimeters cubed. Those are my units, centimeters cubed. Reason why centimeters cubed is because I had 3 centimeters that I had to multiply together. So once I have my volume as being 36 centimeters cubed, I'm going to be able to find my density. So my density, I'm going to write my formula, D equals M divided by V. D equals, my mass is 162.2, then divided by 36. I'm going to make sure that I have my centimeters. And then, so that we have our setup. Sometimes the setup in chemistry is very important because that's all they want you to do. So once you have that, you're good to go. So 162.2 divided by 36 will give us 4.506 grams per, I tried that really hard, centimeters cubed. So our answer would be B. All right, let's go on to problem number 2. It says to determine the density of an irregular shaped object, a student immerses the object in 21.2 milliliters of H2O in a graduated cylinder, causing the level of the H2O to rise to 27.8 milliliters. If the object has a mass of 22.24 grams, what is the density of the object? So I'm going to go ahead and just underline my important information. I have my mass. It said the student immersed the object in 21.2 milliliters of water, and then it rose to 27.8 milliliters of water, and it actually told me to determine the density of an irregular object. So because it's telling me to find the density of an irregular object, I know that I have to subtract my original water volume from my final water volume. So I'm going to go ahead and do that. I'm going to do 27. Oh, wow, that's not a 2. 27.8 minus 21.2. And I get 6.6 as my volume. Okay, so now that's my volume. But then my mass was 22.4 grams, and I still had to find density. So that means I'm still using the density formula, which is D equals mass divided by volume. I don't know what my density is, but I know my mass is 22.4. Right, my units is grams, divided by 6.6 milliliters, because volume can also be in milliliters. And then I have enough information to calculate my density. So I'm going to go 22.4 divided by 6.6. and I get 3.39 grams per milliliter. Now, if we look at this and we look at the answer choices, we're going to notice that we don't see our answer anywhere. So this is an important time that when you don't see your answer, you go ahead and you round up. So 3.39, I can round up to 3.4. And it's 3.4 in the answer choices? Yes, it is letter A. And that is density. If you have any questions, please feel free to ask in the question section or on Google Classroom or on Remind. And I will see you at the live session during periods 4, 6, and 7. Have a great day, guys. Bye.